Recommendation engines are a good topic for student projects. They're a common use of machine learning, and most students will have interacted with them before, like a streaming service that recommends what song or video they might want to listen to or watch. Making a simplified recommendation system, it's a good way for students to get some insight into how these things are made. One example of the sorts of projects I've done with students is to help them make an app that recommends places where someone might want to go on a vacation. They do this by training a machine learning model using examples of how people describe their likes and their interests. Their app can then use that machine learning model to start making recommendations. They tell the app what kinds of things they like, what they enjoy doing, and then the app will use that to suggest a place that they might want to visit, because it's been trained to recognize, to classify different descriptions of likes and interests. What I like about this project is it's a good way of letting students experiment. I like to give the students a little time to play and experiment with this idea and see what happens. So for example, what happens if they add two very similar vacation places? Maybe they train their model to recognize funfair and a theme park. How does their model react? How does it handle that? And I get them to try lots of different ways of doing this. For example, students can try adding many training examples to the training bucket for theme park and hardly any examples to the training bucket for funfair. Now, what they find when they do that is their app will almost always recommend the theme park. Anytime they mention wanting to do something fun or exciting or mention rides or mention adrenaline, the app recommends theme park. Sometimes they can hardly get the app to recommend the funfair at all. Now, I'll ask the students why they think this happens, and they almost always immediately understand the cause. They might not use the same words that I would to describe it. They don't say things like bias, but they will say things like, well, I've told the computer the right answer is theme park loads of times, or I hardly ever told the computer the right answer was funfair. I've seen this be a real surprise to students. Students often start out with this assumption that machine learning systems that are made with the smartest code or the best algorithms, they give the right answers, and that it's machine learning systems with dumb code or bad algorithms that give you the wrong answers. Projects like this, the time the students have to experiment shows them that it isn't just that. In fact, it isn't even mostly that. The biggest impact comes from the person who collected the training examples, what kinds of training examples they collected, how they collected those examples. That realization, that's often a real surprise. It's a crucial insight for students to learn about machine learning projects. Once they understand how this behaves through these kinds of first-hand experimentation and experiences, I ask them what they think of that. What if this was a real vacation recommendation app? What if it really was trained like this, to regularly recommend the theme park and hardly ever recommend the funfair? To be fair, most of the students are unconcerned. They'll say things like, nah, it's just a holiday app, it doesn't matter. So I'll up the stakes. I'll say something like, well, what if you trained the app like this, regularly recommending the theme park, because the owner of the theme park gave you a big sack of cash? Is that still okay? Now, at this point, because money is involved, some of the class will start to change their mind, and some of them will start to argue that this would be a bad thing. But not all. Some of them will still say, it's just a holiday app, it doesn't really matter. So I'll up the stakes a bit further and say, well, what if this was an AI app for doctors? What if this was an app that had to recommend the best medicine to give someone based on a description of their symptoms? And what if the person who was training the app made sure they used a lot of training examples of when one particular medicine was the best choice, and hardly any examples of when another medicine was the best choice? And what if they did all of that because the manufacturer of that drug gave them a big sack of cash? At this point, most of the class will start to be concerned. And I've had classes of primary school students who make amazingly thoughtful and passionate arguments about essentially ethics in AI, or the need for oversight in how AI is used in fields like medicine, the need for transparency in training data that is used for machine learning applications in critical applications. Now, they didn't use any of those words, but children have an innate sense of justice, of what they think is fair, what they think is right and wrong. And with a little insight into what's possible, I've seen that students are entirely able to engage intelligently in these kinds of debates. By experimenting with their own machine learning models, students can see for themselves how easy it is to introduce bias into AI applications, and that enables them to engage in debates about ethics in AI.